So looking at this, I'm going to need to do some algebra before I can even start. So I want you to know this is what you do when you have e to the x plus y. You break it up to e to the x times e to the y prime equals 5. Then I'm going to rewrite this dy as dy over dx. And remember, you want to separate the variables. So I'm going to multiply both sides by dx. And I'm going to divide by e to the x. So the only thing that's left over here is e to the y dy. Now, you see I've got y's and x's separated. So now let's go take the integral. So this gives me e to the y. And remember, I always put the plus c's on the other side. This is going to give me this. Put the e to the x up in the exponent, right? I'm sorry, the negative up in the exponent. Oh, look at that. That's an easy integral. So that's negative 5 e to the negative x plus a c. And then I'm going to solve for the y by taking ln of both sides. So I get ln, and since I'm taking ln of both sides, I'm going to put some negative or absolute value bars there. E to the negative x plus a c. So that's the answer for number 3. More algebra here. I need to separate this root x and root y, and I'm going to rewrite this as dy over dx equals x plus 1. All right, again, you want to get the x's on one side, the y's on the other. So how about we multiply by dx, x plus 1, times dx, and over a root x. And then what's left over here is just root y dy. Okay, so now I'm ready to take the integral. Integral. You know that's y to the 1/2. And so that turns into y to the 3/2 times 2/3 equals, oh dear, what do we do with this? Oh, right, we've got addition in the numerator, so we separate it. So that I can do just easy power rule for each of those. So 2/3 y to the 3/2 is the same as separating here, working with the exponents, and then I get x to the negative 1/2. And then this carries along 2/3 y to the 3/2. So I would get x to the 3/2 over 3/2 or times 2/3 plus 2x to the 1/2. And again, you always put the c on the x side. So now I would multiply by 3 over 2. Oh, look at that. That makes that nice. Multiply this by 3 over 2. That turns into a 3. And I'm just going to put c, because c times 3 over 2 is c. And then I would take the 2 over 3 power of all of this, right, to undo that exponent. So x to the 3/2 plus 3x to the 1/2 plus a c. And you just leave it just ugly like that. Wouldn't want to do any bad math. All right, so that was number 4. So let's come back to number 5. Again, you want to first rewrite y prime as dy over dx, and then you're thinking about separating the variables. Okay, so ln of y times dy over dx equals y x, and that's a cube root of 1 plus x squared. Okay, I'm going to start by multiplying through by dx, and then I'm going to divide through by y. So I get ln of y over y dy equal, and over here I'd get x, the cube root of 1 plus x squared dx. There it is. It's ready. Ready to take the integral. What do I do with this? Oh, I think this is just easy u substitution. Let u equal ln of y. Du is 1 over y. So this side turns into integral of u du. What about over here? Oh, it's another u substitution, right? So u equal 1 plus x squared. Du is 2x dx. So this gives me 1/2 integral of the cube root of u. And so I'm just going to rewrite that as integral of u to the 1/3. Okay. So I'm going to make some room down here so we can go do the antiderivative of both sides. So they're different u's, right, on different sides of the equation, but we can keep track of that. Right. Okay. So over here we get u squared over 2. And then over here we get 1/3, I'm sorry, 1/2. And then we add 1, so you get u to the 4/3 times 3/4. Put the c over here. U on this side is ln of y. And over here I get 3/8. And u on this side was 1 plus x squared. Okay, so then our last job to do is to solve for y. This is going to take a little while to unravel, right? So I would get ln of y squared equals 3/4, 1 plus x squared to the 4/3. And I'm just going to leave it as the black hole c. Then, let me bring it up here so you can see it better. Then I'm going to go and take the square root of both sides. And when you take the square root, you get the plus minus. Again, we'll be solving for the c soon, and so that'll tell us whether it is the positive or the negative. But for now, let's just take the square root. So from here, I'm going to say ln of y equals plus or minus the square root of 3/4, 1 plus x squared, I meant to put the x squared there, x squared to the 4/3 power plus c. And then the final step will be to take the e of both sides. So y will equal the e of the plus or minus. Oh my goodness, this is a huge exponent, right? 4/3 plus c. Okay, one last one. Let's just finish it off. So again, start with rewriting the y prime as dy over dx. And I just put spaces between these things so you could make sure you see what we have here. So let's do this. Okay, so y prime dy over dx. Making room. Okay, so x squared e to the negative y dy over dx equals 4 plus x. Okay, let's multiply by dx and divide through by the x squared. So I get e to the negative y dy equal 4 plus x over x squared dx. Okay, we're ready to integrate. Integrate. You know, little easy La Jolla theorem. This is that, right? Over here, oh, right. We've got addition in the numerator, so we can separate them to two separate terms and take the integral of each of them separately. So this will give me a negative 4 over x. This is like a 1 over x. That's an ln of absolute value of x plus a c. And then over here, I've got this negative e to the negative y. Okay, so first I would multiply through by the negative. So I get a 4 over x minus ln of x. And I'm just going to make it plus c, because negative c is c. Doesn't really matter until we're like actually given information to solve for the c. Then it doesn't really matter. You can just make it a d and then you make it a c. And so then we want to take the ln of both sides. So if I take the ln of both sides, 4 over x minus ln of x plus a c, and then take the opposite of both sides. So negative ln 4 over x minus ln of x plus a c. Wow. There you go.